So does anyone have a chance to look at the essay questions? Exciting, don't you think? So I should have mentioned this last time, but I'll say now. With those questions, I know for some people it's tempting to do a bunch of extra research to try and come up with all these different answers and perspectives. That is not what I want you to do. So I expect your answer to really rely on all the material we go over in class. You do not need any other information from outside of class to address the question, right? Any of those questions that are on there. So keep that in mind with when you develop your answer or your response, that it should be based on what we've gone over in class. You do not have to go spend a bunch of time at the library trying to look up a bunch of stuff. That's not what I want you to do. I want you to apply what we've gone over in class to these questions. Okay. Any questions about that? No. Yes?
What's the minimum length of the response? Because the question number 3 technically can have 5 versions because
Right.
5 phases.
Right.
So are you expecting from us to write a whole page about every single phase?
So there is no minimum that that your response can be. There's a maximum. You can't write more than a page and have it count. Some people are able to word things much more concisely and get them in fewer words than others. So really this is part of the exercise too, is you need to be able to express your answer in a concise enough way that it fits on a page, but you've got to be able to include enough details to show me you know what you're talking about as it directly relates to the question. So a lot of times people write out these really great long answers or responses, but they don't necessarily relate back to specific parts of the question. And then I can't give you credit for it, even if it's a brilliant writing. If it doesn't address the question, then I can't give you credit for it. So when you work out your answers for this, make sure that your answers can relate back to specific parts of the question. I try to write a lot of these questions so that there are sort of parts to it, and it makes it easier to grade, right? So I look for this part and I look for that part. So in your mind, try to break down those questions that way. Guess how I might actually grade it. And make sure that you address each part of the question. People always burn themselves on these essays by maybe spending their whole page talking about the first half of the question and totally forget the second half. Well, you do that, you can only get half the total points. So what's that, 5.5% of your grade as opposed to the full 11, something like that? So don't do that. Make sure you address all parts of the entire question. Anything else? No. Okay, so we were talking about the endocrine system last time. I want to talk about one more example from it. We'll look at calcium balance as it relates to the endocrine system. And then we'll start our next organ system, the cardiovascular system. We haven't, one of the essay questions is related to the heart. We haven't got over there yet, but we're getting there. Okay, questions about what we went over last time? No. Right, we went over an example of growth hormone and looked at where does it come from, what controls it, what are the results if there's too much or too little. Now let's go ahead and take a look at calcium balance. All right, so calcium is a really important ion in our bodies. Right, we've talked about it with a few different systems already. Right, it's important with the nervous system. Right, it's related to passing signals from one neuron to the next through a chemical synapse. It's important in muscular system. Right, it's involved in turning on the siding filaments. Right, so getting myosin and actin to interact, whether it's the skeletal muscle, smooth muscle, and we'll see in cardiac muscle also. It has some other roles in cardiac muscle too. So if you've got too much calcium or not enough calcium, it's going to screw up your nervous system, and it's going to screw up your muscular system. You want to keep real tight control over how much calcium is available. Okay. And the endocrine system is heavily involved in that. So let's take a look here. Input. How do we gain calcium into our body? It's all through what we ingest, right? What we eat or drink. So through our food. That's how you add more calcium to your body. How do we lose calcium? Right? We can lose it with our kidneys. Right? When our kidneys filter our blood and create urine, you can get rid of some calcium that way in your urine. You can also get rid of calcium in feces. So most of our waste we get rid of through the kidneys, the renal system, but there are some things we can get rid of through the digestive system. All right, so in between the input and the output, where is the calcium, right? In our body, it can be in a number of places. It can be in the ECF, or extracellular fluid. So that's the fluid, the water around our cells. Intracellular fluid can be in our cells. Keep in mind that cells generally maintain a pretty low calcium concentration in the cytoplasm. So if it was in our cells, for instance in skeletal muscle, it'd be in our sarcoplasmic reticulum. And then also our bones. So our bones are is the main source of storing calcium. Right? Calcium in the ECF and ICF, that's where we're sort of using the calcium, and you can think of it as being stored in their bones. We use it in our bones also. That's what helps make our bones nice and stiff and rigid so they can do the things for us that we need them to do. But also think about your skeleton as a storage area for calcium. If your body's a little low on calcium, instead of waiting for your next meal, you can go ahead and access some of that calcium from your bones. You just dissolve part of your bone, liberate the calcium, you're good to go. Okay. All right, calcium hormonal control. So what are the hormones involved here? So we're going to talk about parathyroid hormone and calcitonin. So these are two hormones involved in balancing the amount of calcium that's available in our body. Okay. All right, we're going to start with parathyroid hormone, and then we'll talk about what calcitonin does. All right, so parathyroid hormone, the source. You can probably guess where this hormone is released from. It's the parathyroid gland. And the name tells you where it is, right? What does para mean? Around. So it's around the thyroid. That doesn't mean it just kind of floats around wherever it wants to, but it's found on the posterior side of the thyroid gland. So let's take a look there. So we're looking at our neck, and draped over the trachea, right below the larynx, we've got this sort of butterfly-shaped gland. That's the thyroid gland. And if you were to sort of peel that off and look on the back, right, these little nodules here represent the parathyroid gland. So it's actually attached to and on the back of your thyroid gland. All right, the stimulus for release of parathyroid hormone would be a decrease in the calcium ion concentration in your blood. So if you have less calcium in your blood, it drops down. That causes or leads to the release of more parathyroid hormone.
Can you repeat that?
What did I just say? If you have a drop in the calcium available in your body, then you release more parathyroid hormone. Okay. All right. What is the action? What happens once you get more parathyroid hormone? It increases the amount of calcium in your blood plasma. As we can see, this is going to be a negative feedback mechanism. The stimulus is a drop in calcium. The response is release parathyroid hormone, and that raises the amount of calcium available. Of course, the question is, how did it do that? Well, for one, it increases osteoclast activity. Osteoclasts are a specific type of cell. The osteopart tells you that they are bone cells. Right? In clast, cells that end with the name clast are cells that break things down. So osteoclasts break down the mineralized part of bone. They're dissolving that mineralized part, making those calcium ions available, allowing them to enter the blood. So if they become more active, they break down bone at a faster rate, making more calcium available. Yeah?
To clarify, so decrease of calcium, increase of the hormone, increase of calcium, the hormone just like stays dormant, or it actually physically like without less.
So the parathyroid gland is responding to the amount of calcium available. So if the calcium levels drop down, it becomes more active. And as it becomes more active, that leads to a number of steps we're about to go through, and one of them we just talked about, leads to the calcium level coming back up. So as it comes back up, the parathyroid backs off on its release of parathyroid hormone.
That's what you mean by the action part of this slide.
The action, yeah, what happens in response to releasing the hormone? What is that? What do the target tissues do once they receive that hormone?
Okay.
Yeah. Anything else for now? All right. So what else happens in response to parathyroid hormone? Increase renal reabsorption. Right, so we haven't really talked about what this is yet. We talk about it near the end of the semester, which I feel like it's coming very fast. So renal refers to kidneys. And reabsorption is kind of like absorption, which we haven't talked about that yet either, have we? That uncomfortable quiet. How are we going to summarize this real fast? So your kidneys, when they filter blood, they take a subset of your blood, and they sort of look for the things they want to get rid of, and look for the things they want to keep and hold on to. Think of reabsorption at this point as the stuff they want to hold on to. So if you increase renal reabsorption of calcium ions, you pee less of it out, you hold on to more of it. So that's what you should get out of this for right now. Does that make sense with renal reabsorption? So you hold on to more calcium with the kidneys. And then you also increase intestinal absorption. So all that stuff that you swallow, you stick in your mouth, goes in your gut. Right, you're going to absorb the nutrients that you've ingested going across the wall of your gut. Some things get absorbed more easily than others. For calcium, it's going to have certain requirements. And the presence of parathyroid hormone causes the intestine to be able to absorb more calcium than it would otherwise. So it's going to take more calcium out of the lumen or space in your gut and bring it into your body. Okay? So we are breaking down a little bit of bone to liberate calcium ions. We're going to pee out less calcium. We're going to hold on to more calcium. And we're going to absorb more calcium that's going through your gut. You're going to put more of it in your body. So we're trying to keep the calcium that we have, and we're trying to add more calcium to our body, and we're trying to get some calcium out of storage. Does that make sense? So all of those are going to lead to more calcium in the blood. Yeah?
Do those happen all at the same time, or does like one contributing more calcium than one of the other three actions that are happening?
Yeah, I'm not sure what their relative contributions are for a given amount of parathyroid hormone. I'm not sure. Anything else? Yeah.
So you said that we get amount of bones or something,
Mm-hmm.
I mean calcium from the bones. So later on when we like eat more calcium, is the calcium go back to this area where the bone are?
Yeah, so you have these cells, osteoclasts, are breaking down bone. They're always breaking down some bone in your body. But you also have another type of cell called osteoblast with a B. Those are always building back up bone. And you've got these cells right there. So you're eating it away, you're adding it back. And really it's their relative amounts that determine, are you getting a net gain of available calcium ions, or are you storing more calcium ions? So if you're adjusting the activity of osteoclasts, let's say they're both doing their job kind of the same rate, there's no net change in your skeleton. If osteoclasts all of a sudden start working harder, you've got more calcium available. But then later, you eat your calcium sandwich or whatever, and you add more calcium to your body. Now those osteoblasts are going to be, working to put that calcium back. Okay? All right. What do we have here? Here's a flow chart that summarizes this. So, in the beginning, right, we have a drop in the amount of calcium in our blood. Stimulates the parathyroid gland to secrete more parathyroid hormone. So that parathyroid hormone then will trigger the kidneys to excrete or get rid of less calcium. It also leads to stimulating the intestine to absorb more calcium. And we're going to break down or reabsorb some calcium from our bones, making that more available in the blood. All of that leads to a rise in the plasma calcium ion concentration. All right, so this slide just summarizes what we went over in the previous slide.
I have a question.
Yeah.
Just confusing. If you like don't eat calcium for the whole year or more, and your body is just like taking calcium from the bones, what happens?
Then your bones break. Right? So if you do not have calcium in your diet, right, you're not getting calcium in your body, you keep using calcium, and sure, your kidneys can try to hold on to it, but you're still going to lose some of it. Right? No system's perfect. And so you can run a deficit of calcium. That'd be bad news. Okay? All right, so in kind of along the same lines, instead of depriving your body of calcium, what if your parathyroid hormone was working too hard and released too much parathyroid hormone? What's that?
Kidney stones.
Kidney stones? Well, yeah, actually that could, because if you've got extra of anything really in your blood and going through your kidneys, it can form a precipitate and the little calcium crystals, and that is not supposed to be very comfortable at all. Yeah?
When they have too much calcium, can it also cause overforming of like bone, and so, or maybe I'm thinking about the disease where like basically you can stone a person because you've had too many bones growth.
There's an autoimmune disorder where you get
Basically,
turning to stone, but what is that? Is that calcium?
I don't know.
Not quite sure. Yeah, I mean, there are situations where you can have, this extra sort of calcium deposits. You've got extra calcium in your bodies, and they can form these deposits, and it's almost like forming new bones or different bones or sort of chunk of bone material. Excess of parathyroid hormone is not going to do that in a way, it's going to do the other. So it's going to, think about the osteoclasts. Those become hyperactive, they keep wearing away bone, outpacing the osteoblasts that put bone back, and it starts to make your bones thinner and weaker. And one of the places this starts to show up first is in the pelvis or the hips. So here's an x-ray of someone that has too much parathyroid hormone, and it actually forms divots or dimples in their pelvis. And so all these gray circles are actually depressions in the bone where bone material is missing, and there's these little, almost like golf ball dimples, right, in the bone. And these hips now have a lot less bone mass on them than they did without this extra parathyroid hormone. So the pelvis is more fragile and more prone to breaking or getting injured. Right? So, bad news. All right, let's talk about the other hormone, calcitonin.
So is that osteoporosis?
Now, so osteoporosis is, it's also getting, thinner bones or lower bone mass. But that has to do not necessarily with parathyroid hormone, but instead the balance between osteoclasts and osteoblasts. As one gets older, the osteoclasts, the cells that, I got this all screwed up. The osteoblasts, the cells that lay down bone, are less active. And so you're not laying down as much bone, but you can still take bone away.
Okay.
Right? And so those cells are getting sort of out of balance in a different way. And the idea, the thought to help minimize the effects of osteoporosis is, okay, you're going to go into this stage of life where your osteoblasts are not as active. So let's go into it with more bone mass. So if you start with more bone mass, then it's going to take longer to wear that down until those bones are fragile. So if you can sort of trick your body into making heavier, thicker, denser bones, then you got more to work with when you go into that stage. And so then, make sure you ingest a lot of calcium so you have calcium to work with, expose your body to these minor stresses that trigger the development of denser and thicker bones, like medium impact activities, things like that. Yes?
Would that cause, I think it's like called like Glassman syndrome, where basically they just break the bone by just touching things practically, where the bones are so brittle that they're constantly
I'm not sure what that is from. It sounds like it's not just osteoporosis or something else going on there, but I'm not sure. What was it called?
I don't remember exactly what it's called, but I think it's like the Glassman syndrome, where basically you literally can bump into a table and then you just fracture
Yeah.
because your bones just.
It sounds like the way the bone material is laid down is not quite right. It makes it more fragile, but I don't know for sure. I see another hand shoot up over here. No? Anywhere else? All right, so the next hormone, calcitonin. You can kind of think of this as having the opposite effect as the parathyroid hormone. The source is from the thyroid gland. So Right in front of the parathyroid gland. The stimulus, what triggers the release of more calcitonin would be a rise in calcium ion concentrations in the blood. So if you've got extra calcium in your blood, you're going to release more calcitonin. What's the action? It's going to bring that level of calcium back down. Help you maintain homeostasis. So to do this, you decrease, it leads to a decrease in osteoclast activity. Remember, those osteoblasts are building bone in the background, and if you just adjust the activity of osteoclast, right, if you adjust that level so it's below that of osteoblast, then you've got net building of bone. Parathyroid hormone increases the activity of these osteoclasts, and then you'd have a net reabsorption of that, or absorption of the bone, or breaking it down. Right. So calcitonin is working through the osteoclast. It's the opposite effect that parathyroid hormone has. Yeah.
I don't fully understand the word action in this.
Think about it as the body's response to this hormone, calcitonin. Right? Or what do cells do in response to receiving calcitonin? Anything else? All right. Another organ system down. All right, let's start the next organ system, the cardiovascular system. Cardiovascular system. So just give you kind of a quick overview of the system first, and then we'll get into talking about the heart specifically. After we get through the heart, then we'll talk about blood vessels and blood. That's sort of our plan there. To think about it as simply as possible, what the cardiovascular system really is and made up of. You can think of it as really a set of hoses. Those hoses are the blood vessels. Right? So you've got these hoses or pipes, whatever you want to think of it as, running all through your body. And we've got one main physical pump, and that is the heart. So the heart is going to be this main driving force. There's some accessories that help out with this. We'll talk about those later. But the heart is this main pump that's driving fluid through these hoses or blood vessels. And then, of course, what is that fluid? That's blood. So the whole cardiovascular system is this pump with this network of vessels to drive the blood all through the body. Okay, everyone got that? All right, so here is one representation of our cardiovascular system. In the middle of this drawing, we've got the pump. Here's the heart. And connected to the heart are all these different blood vessels. And of course, the whole system is filled with blood. So as this heart squeezes down its contents and squirts the blood out to the different parts of the body. And then that blood comes back to the heart. So it keeps circulating around and around. All right. What about the functions of the cardiovascular system? What is it really doing for us? How does it help us maintain homeostasis? Well, for one, it transports nutrients. If you, let's say, absorb amino acids in your gut, how are you going to get those amino acids to all the different tissues in your body so they can use it? Well, you're going to get it there through the cardiovascular system. You're going to pump it throughout your body. You do not rely on diffusion. Right? Diffusion, remember, is too slow over longer distances. That wouldn't work. So we transport nutrients with our cardiovascular system. But also, we transport waste. And a lot of times people sort of forget this part. But it's not just the good stuff that's in our blood. There's also stuff in there we don't want anymore. So all of these tissues in our body that are using those nutrients, they're metabolizing, they're all producing waste products. And they cannot hold on to their waste products. If they do, it becomes toxic. So you've got to get rid of this stuff. And so we dump a lot of it into our blood, and that circulates through, and then we've got organs that pull those waste products out and we get rid of it. mostly those are our kidneys, and that's what urine is getting rid of the waste products from our blood. The cardiovascular system also is important for cell-to-cell communication. Right? You can imagine one cell communicating with a neighboring cell, maybe through gap junctions, or releasing a paracrine, some chemical messenger that goes next door. But what if you want one part of your body to talk to a completely other end of your body? How are you going to get a message down there? Well, you can use the cardiovascular system, right? If there are neurons that connect them, well, you can use that, and that goes really fast, efficient, and directed. But if you're going to use the endocrine system, you rely on the cardiovascular system, which helps to sort of point out how dependent all of our systems are on each other. I think I mentioned this at the beginning of the semester. It's really hard to talk about one system without talking about another system along with it, because they all work together so closely. All right, so cell-to-cell communication is important. Body defense. So we have a number of cells in our blood, the white blood cells, that help defend us against organisms that are not healthy for us. We might consider that don't belong in our body. Right? And in a way, this ties in with the next organ system. We'll talk about the lymphatic system. We'll get to that later. But the cardiovascular system is really important in this body defense. How are we going to distribute these cells that protect us from these foreign organisms? Through the cardiovascular system, in part. Another one that I think is sort of the least appreciated or thought about is heat distribution. So our cardiovascular system is really important with heat distribution. Right? Our body is sensitive to different temperatures. We really like to be within a very narrow range of temperature. And as we use our tissues, if the metabolic rate of certain tissues increases, it produces more heat. You want to get that extra heat out of there. And so by running blood through that now warmer, say, organ, maybe it's a skeletal muscle, right? You've been jumping up and down, and so the muscles in your legs are producing lots of heat. The blood that runs through those muscles can actually get some of that heat out of there and distribute it to other parts of the body. Right? For instance, the skin. So you run warm blood to your skin, and that heat can then radiate out into the environment, and you can lose some of that extra heat. And so the cardiovascular system is really important in that. In a way, you can kind of think of it working similarly to the radiator in a car. Right? Your engine's all kinds of different parts in the engine related to the engine produce a tremendous amount of heat. You're running all this coolant through, water plus whatever other mysterious chemicals are in antifreeze and all that stuff, runs through, and it grabs some of that heat from those heat-producing parts, sends it through the radiator, which is all those little metal fins that has cool air running over it, sucks the heat out, dumps it into the environment. Okay. All right, questions about the functions of the cardiovascular system? I feel like the room's getting warmer. You guys aren't dumping heat, and some people are kind of doing this. I feel the same way on the inside, but I'm trying to hide it.
Does it also warm can't the blood also warm the body too? Like you said, it helps it cool down.
It can. So if you're trying to get rid of heat, it helps it cool down. But if you're trying to warm up, let's say you're cold, right? Now you do a bunch of jumping jacks to create some heat. That blood will help distribute that heat to different parts of your body as well, right? Or that expression, right? If your feet are cold, put a hat on. You guys heard that? A few people have. They're like, what? Where's he going with this one? Right, so if your body has this net loss of heat, right, it needs to distribute its heat so that it sort of protects the more sensitive parts of your body. Your head's pretty darn sensitive. You don't want bad things to happen to your head. You don't want bad things to happen to your feet, but your head's a little more important. Right? You can live without a foot, you can't live without a head. Right? It sounds kind of obvious and silly, but and so if your body is losing heat, it's going to divert whatever warm blood it has or some of that more towards your head to make sure your head stays at the right temperature. And where is it going to take that from? From your extremities. So you'll have less blood flow to your arms and your legs. Right? And your feet are at the end of your legs, they're going to get sort of the shortest end of the stick. And so now you've got minimal blood flow to your feet, hopefully enough to keep your feet alive, but it could be cold enough where it isn't, and then you get frostbite and it turns black and kind of drip off and it's really nasty. You don't want frostbite, right? So your feet now are getting cold because you're allowing more heat to go to your head than you're than to your feet. So you put a hat on, that keeps your head warm, so you lose less heat through your head. You don't need as much heat to your head, so you can send more of it to places like your feet. So sure, warm socks would help, but you gotta take care of your head first. So maybe you should have packed a warm hat and warm socks. And not get frostbite. What's that?
A scarf too. I have experience when I put maybe a scarf, even if I don't have wearing too much, I feel very warm.
With a scarf?
Yeah, maybe a scarf.
You lose a lot of heat through your neck?
No, it makes the head warmer, but
Yeah.
that makes the whole body heat. I don't wear too much clothes.
Right, so there are, if you're trying to sort of minimize the amount of warm clothes to bring, you can sort of concentrate on everything above your shoulders, which isn't as big and bulky as like a big jacket or whatever, and you get a lot of heat bang for your buck out of smaller clothes, I guess? Yeah. Yeah. All right. Let's go back to looking at those cardiovascular parts. So we're going to look at a little more detail now. So, I mentioned we've got the heart, we've got the vessels and the blood, but there are a number of types of vessels. They're not all the same. So one type of vessel that we have are arteries. Arteries. So arteries are blood vessels that always carry blood away from the heart. So when blood leaves the heart, it goes into an artery. We also have veins. It's another type of blood vessel. Veins always carry blood back to the heart. So when blood enters the heart, it just came from a vein. So then the question is, all right, well, as blood leaves the heart, it goes into an artery, and eventually it turns into a vein and comes back to the heart. At what point does that artery switch over to becoming a vein? Well, it doesn't. There's something else in between the two, and that's really the indicator of when you're no longer leaving the heart, but now you're coming back to the heart. And those vessels are capillaries. So the capillaries join the arteries to the veins. There are a couple exceptions in the body, and that'll come up later. But for the most part, capillaries mark that sort of far point away from the heart. In some ways, you can think of the capillaries as really being the most important part of this whole cardiovascular system. Really, all parts are equally important because the whole thing falls apart without them all. But the capillaries is really where all the action happens. This is where all the exchange is between your cardiovascular system and all the other organ systems that it serves. The rest of the system is just to transport the blood to and from capillaries. And so capillaries are where all the exchange occurs. All right, and then we also have the heart. So capillaries are that lead from arteries to veins, where you can think of the heart leads from veins to arteries. So the heart gets blood from veins, and it gives blood to the arteries. And remember this from the lab that we had just